We'll continue right triangles and similarity as we get into trigonometric ratios. Learn some trigonometry today. And in our trigonometry, we'll learn SOHCAHTOA, a famous saying in trigonometry. And by the end of class, you'll learn what those stand for and how you can use them, and how you use them with right triangles. We'll find out how this trigonometry helps us because we'll talk about similar right triangles. So let's get started with the tangent ratio. Let's learn what that is. But first of all, in order to do that, I'll need you to do some work. So you need to draw some segments in your notes there. And you need to draw segments AB and BC to form triangle ABC. And you want angle C to be a right angle, 90 degrees. So it doesn't matter the length, you can draw whatever size you want, but you're going to draw in AB and BC. So this is point B. After you've done that, you need to draw segments C prime, B prime, and C double prime, B double prime, such that B prime and B double prime are on line AB, and C prime, C double prime are on line AC, and that CB is parallel to C double prime, B double prime, and C prime, B prime. So it'll look something like this once you're all done. Like I said, you can figure out where you want those lines. You can put them wherever you want. I'll just make sure that they're according to the directions there. So B double prime and B prime will be on line AB, and C prime and C double prime will be on line AC. Now, what principle proves that these triangles will be similar? So we've got three triangles you can see, and hopefully through what we've learned already this year, you know that by angle similarity, since these are parallel lines, we've got corresponding angles here that are all congruent, and these are all 90 degrees, and they even share this angle down here, angle A. So by AA similarity, we know that those are going to be similar. And what is true about the parts of these triangles? Well, we know that the angles will be congruent. What's true about the side lengths? Lengths should be proportional. So angles are congruent and lengths are proportional. And I don't think I'll fit that all on the page. So next, we need to do some measuring. So you're going to measure all those lengths that are asked for. Write those down, get out your ruler and do that. And then get out your protractor and measure angle A. And then what you need to do is find the following ratio. So you're going to divide the two segment lengths and get an approximate ratio for all three of those. And then on your calculator, you're going to take the tan of the angle. So let's say that my angle was, let's say that it's 55 degrees for measure of angle A. So let's say this is 55 degrees. And on my calculator, I'll take the tangent ratio. So first of all, I want to make sure that my calculator's in degrees mode, not radians. So if you need to change that, go down and adjust that. Then once that is taken care of, you'll take the tangent of 55 degrees. And it gives me 1.428 is the ratio, that tangent ratio that we're taking. And I would put that in there. Okay. So after you do all that calculation, obviously for your angle, you got to measure it and figure out what it is for yours. You might have a different number. But I'd say the tangent of A is, and we'll figure that out in a moment. So do your calculations, then restart the video when you're ready. All right, so hopefully you noticed that with all these ratios, all the following ratios should have been the same as that tangent on your calculator if you did everything correctly and did all your measurements right. The reason that works is because you're comparing similar sides of triangles. Similar sides are proportional, so you should get the same ratio every time. And that tangent calculates the ratio. It says for any triangle with 55 degrees in a right triangle, it's going to have that ratio of opposite side over adjacent side. So what we're talking about from measure of angle A, BC, and AC. So BC, as we're looking at it, is the opposite side. So from this angle, this is the opposite side. And this would be the adjacent side, is what we called it in the triangle. And this we would call the hypotenuse. So tangent of A is equal to opposite over hypotenuse. And that's the ratio that we'll use for the tangent ratio. That tangent ratio, as we find, will always be the same. Oops, I did that wrong. It's not opposite over hypotenuse. It should be opposite over adjacent side. In any right triangle, it will always be the same. That's why when you type it on your calculator, you can get a value. Okay, so that is TOA. Tangent equals opposite over adjacent. And on our calculator, we call that tan. Tan equals O, opposite over adjacent. So if you can remember that phrase, TOA, you remember the tangent ratio. Tangent ratio equals the opposite side divided by the adjacent side to that angle. And we refer to the tangents with the acute angles, not the right angle. So if I want to find the tangent of J, the tan of J, so as I'm looking at it, 24 is the opposite side. 32 would be the adjacent side from J. I know 40 isn't the adjacent because that's the hypotenuse. It's across from the right angle. So 24 over 32. And we can round it to 4 decimal places. So 24 divided by 32 is 0.75. So the tangent of J equals 0.75. Now the tangent of K, we do the same thing. Looking at angle K, except now the opposite side is 32 from K. My adjacent side is 24. So tan of K, tank, so tangent of K is 32, which is the opposite side over the adjacent side of 24. So 32 divided by 24 is 1.3 repeating. So the tangent of K, if we want to go to 4 decimal places, 1, 2, 3, 4. So we'll abbreviate that way. So that's the tangent ratio. Well, we can use the tangent ratio knowing that all triangles would be similar. So if I have a right triangle with angle of 32 here, the opposite side is 11. The adjacent side is x. If I want to find that, I just set up a proportion. So tangent of 32 degrees is equal to opposite over adjacent. Okay, so now we just solve that equation. In order to get x by itself now, I need to multiply both sides by x. So I have x times the tangent of 32 degrees equals 11. Now to get x by itself, I divide both sides by the tangent of 32 degrees. And divide over here. And I'll have x equal to 11 divided by the tangent of 32 degrees. So here's where you will want to consult your calculator. So 11 divided by the tangent of 32 degrees is about 17.6 to the nearest tenth. So we'd say x is approximately 17.6. So that's where it's helpful, because we know we have similar triangles and similar triangles are proportional. So why don't you set up an equation to solve for h, the height of the lamppost. Restart the video when you're ready. Alright, so as I take a look at angle 70 here, the opposite side over the adjacent side, so tangent of 70 degrees equals h over 40. Multiply both sides by 40. So I'm left with 40 times the tangent of 70 degrees equals h. And multiply that out, I get about 110 inches. So we get those ratios on our calculator. Here's how we can figure out the exact ratio. Let's say we have one of those special 30, 60, 90 triangles that we talked about last lesson. We know that the shorter leg times the square root of 3 gives us the longer leg. And we know that the hypotenuse is double that. If we know this is the 60-degree angle, because remember this is part of our equilateral that we split in half. So the opposite side is square root of 3 and my adjacent side would be 1. So tangent of 60 is equal to opposite side square root of 3 over adjacent side 1. So the tangent of 60 is exactly square root of 3. And when you type it on your calculator, it gives you this number approximately. But that might be helpful, and it will be helpful later on as you get into pre-calculus and calculus as you start working with those special trigonometric ratios a little bit more to know the exact measurement. Next, we'll talk about sine and cosine. Sine is so, and cosine is ca. So the sine ratio in the right triangle is any acute angle, and that ratio is the adjacent side over the opposite. So can't talk today. So sine is the opposite over hypotenuse. The ca is cosine, or cos on your calculator, is equal to adjacent over hypotenuse. And just to note, the sign on your calculator is abbreviated sin. Okay? So that's in your notes there too. It's just taking a look at the different side lengths that we talked about with the tangent. So if we want to find the sin of S, the sine of S, and the sine of R, so if we're looking at angle S, sin, opposite over hypotenuse, opposite side, hypotenuse. So 63 over 65. And then we can divide that. 63 divided by 65 is 0.9692. And I'll just write that here, 0.9692. Okay, I'll ask you to find the sine of R. And then let's take a look at cosine. Cosine of U. Cosine is adjacent over hypotenuse. So if I'm looking at U, adjacent would be 18, and hypotenuse would be 30. So cosine of U is at 18 over 30. And when I divide that one, I get 0.6. So why don't you pause the video, see if you can find the cosine of W and the sine of R. Okay, so sine of R, as I'm looking at R, sine is opposite hypotenuse, so the opposite side from R is 16, hypotenuse is 65. Hypotenuse is always the same, so 16 divided by 65 is 0.26 or 2462. Cosine of W, adjacent over hypotenuse, so adjacent side is 24, hypotenuse is 30. 24 divided by 30 is 0.8. So now, just like with the tangent ratio, we can set up equations to find missing values in a right triangle. So if I'm looking at angle 80 here, I'm trying to find this side, which would be the opposite side. And 10 is across from the right angle, so that would be the hypotenuse. So if I can remember the phrase, so ka toa, I can take a look at my diagram and what I have and figure out which ratio I need. So this 80 degrees, I have O and H, OH. So sine of 80 equals opposite over hypotenuse. Once I have that set up, it's just a matter of solving for x. So times 10 on both sides. 10 times the sine of 80 will give me x. And when I take 10 times the sine of 80, what I get is a value of 9.8 approximately. So x is about 9.8. That should make sense in our figure. Yes, it's less than 10. Why don't you try the next example? Make sure once you pause that video, try it on your own. Restart it once you're ready. Now once we're ready, we will set up the equation. So I know 55 is my angle. I know the adjacent and the hypotenuse. AH is cos, so cosine. So cosine of 55 equals adjacent over hypotenuse. Multiplied both sides by x. And after I multiplied both sides by x, I divide by the cosine of 55 on one side and on the other side. So once I did that, 12 divided by the cosine of 55, got approximately 20.9. Now, something we need to consider as we're talking about trig ratios is angles. So if I'm looking up, we refer to that as an angle of elevation. If I'm looking down, that's an angle of depression. In this example, I'm skiing down a mountain with an altitude of 1,200 meters. Angle of depression, I'm looking down, 21 degrees. So if I'm looking from this angle across, it's my opposite side. Distance down the mountain would be hypotenuse. So OH, which one uses OH? So katoa. So sine of 21 degrees equals opposite 1,200 over hypotenuse. Or, since I know that 90 plus 21 is 111, subtract that from 180, 69 degrees in this angle. So I could also look at that angle from the opposite perspective and say, well, this is my hypotenuse still, but this is my adjacent side. AH is ka. So the one that uses ka is cosine. So I could say cosine of 69 degrees be equal to adjacent over hypotenuse. So I can set it up either way using either acute angle. Just got to use my reference point from there. So once you solve either one, restart the video when you're ready to check your answer. So as you can see, either way you have to solve it. We've got to multiply both sides by x and then divide by cosine of 69, or in this case by sine of 21. And then we get approximately 3,348.5 meters. Next case, we want to build a skateboard ramp with a length 14 feet. Angle of elevation that's going up from the ground 26 degrees. We need to find the height and length of the base. So I can find either x or y. It doesn't matter which one I find first. So let's just go with x since that comes first alphabetically. That's opposite. And that's hypotenuse. So OH, so katoa, so sine. So sine of 26 equals opposite over hypotenuse. Why don't you take the time to solve that one and then figure out how to get y. Okay, so I multiplied both sides by 14. 14 times the sine of 26 is about 6.1. So this length is 6.1 feet. So two ways you could do this. Since this is a right triangle, I can use Pythagorean theorem. So 6.1 squared plus y squared equals 14 squared. Solve that down, I got y is about 12.6. Or if we want to use trig, this is the adjacent side, hypotenuse. So AH ka. So I did cosine of 26 equals adjacent over hypotenuse. Multiplied both sides by 14. 14 times the cosine of 26 is 12.6. So either way it works. So Pythagorean theorem, if we know two sides, or if we just know one side and an angle, we can use trig. And here's where we get that special right triangle again. Remember this equilateral triangle. We know this side is 1 to 2. This side is doubled to the hypotenuse times square root of 3 to the longer leg. And this shows the exact lengths. We get approximations in our calculator, but sine, remember sine is opposite over hypotenuse. So sine of 60 is square root of 3 over 2. And that's the approximation. But here's the exact measurement, which you'll find useful as you further your math career. Cosine is adjacent over hypotenuse, so 1 over 2, 0.5, and that's why it's always 0.5. because it deals with that equilateral triangle. So we learned the trig ratios, we learned how to apply them. You can do some practice in there, and always remember, so, ka, toa. Keep those words in your mind as you do your work.